Welcome everybody. It's great to have you for this joint meeting between the Ottawa and Toronto SMPTE chapters. And thank you, Tony. This is great. Really glad to do this with you. You guys have been awesome to work with.
Yeah, likewise. I think this is great that we get co-meetings together. I think from a Toronto's perspective anyway, we want to do more of these, and all of our sections have various topics that they're interested in, and I think sharing it with the greater audience is good. So thank you for even asking us and inviting us to share this evening with you.
Yeah, very happy to. So tonight's sponsors, Ross, of course, and you can see it behind me. This is my normal, it's what's there all the time. And of course, the SMPTE Toronto Technical Conference.
Yeah, I'll speak a bit more about that later. And yes.
So tonight's agenda. So we have a quick intro between myself and Tony. Then it's going to be followed by a presentation by Michael Martin doing an overview of LEO. We're gonna have a short break, just 5 minutes, give you a chance to, run to the washroom, etc., come back. Then our second presentation of the night from Telesat, and then we're gonna have a short Q&A, and then we're gonna let you out of here. So that's what tonight's evening looks like. Quick thing, this is just for the Ottawa chapter. If you don't know us, I'm the chair, I'm Troy English. In my other life, I'm also the CTO for Ross Video. And our secretary and treasurer, who is probably online, I haven't checked, is Jeff Moore, who's the executive vice president at Ross Video, as well as the chief marketing officer. And a big thank you to all our committee members in Ottawa, because these things don't just happen. And I tried to get a picture of Tony, but he was being shy, but you can all see him right there. So this is just a quick reminder of the SMPTE Montreal boot camp. We do a lot of work in the Ottawa chapter with the Montreal chapter as well, because they're just kind of a drive down the road from us. So it's taking part in early June with focus on security, but there's gonna be more details forthcoming. So we just wanted to give that as a reminder that's upcoming. Tony.
And likewise for us, the Toronto TTC 2021 is in the stages of coming together. Our dates are June the 15th to the 17th, so it's going to be a 3-day event, but it'll be more of a half-day event. We're going to stagger the second day so that our partners in the western part of our country can partake in as well. And so the theme is media fast forward. We've got various topics that we're looking to partake in, anything from VR to AR to UHD, IP. The best thing, just point your browser to simpte.org sections/TTC 2021, and you'll start seeing all the information that we have compiled. And there is still a call for presentation. So if you've got a topic that you'd like to speak about, or some of the topics that we are focusing on, and likewise, if you are a company and you want to sponsor this event, we are looking at engaging with sponsors, and there's a myriad of possibly reasons why you want to do that. But yeah, just point to the browser, you'll see all our contact information, and we'd love to engage with you.
Great.
Thanks, Troy.
Yeah, my pleasure. So yeah, so these are the presentations, as we've said earlier. Michael Martin's going to be doing one on LEO itself, giving an overview. And I'm going to move, we have intro slides coming after. So just a quick thing tonight, I'm going to be introducing and reading the presenters' bios. Eitan is going to be taking notes of your questions. So if you've got questions, please put them in the chat room. There's also a question section, and Eitan's going to look at both of those. And we do the Q&A at the end. He's going to moderate that. And I also wanted to give a really special thanks out to both Eitan from the Ottawa chapter and Jamie from the Toronto chapter for pulling this together. it's actually quite a lot of time and effort and a lot of meetings to get evenings like this together. So a huge thank you to them for all the hard work and you know, making Tony and I look good. We just have to sit up here and look pretty and say a couple of words, but others do a lot of the work. Okay, so with that, so a quick intro for Michael. So Michael Martin is the Vice President of Technology with MeterCore. He leads MeterCore's technology direction for complex RF systems used for wireless smart metering and data communication networks. Michael provides business and technical guidance to municipalities across Canada. Previously, Michael consulted on RF systems with IBM worldwide for 15 years, and prior to IBM, he served as a systems integrator in the broadcast industry for 31 years. He's a dedicated lifelong earner with 3 master degrees, as well as he holds 3 undergrad diplomas. And by the way, now I'm feeling like I think I have to go back to school now. He also holds 5 certificates in a variety of subjects focused on communication technology and media technology. He's served on the Toronto section of the SMPTE Board of Governors for 16 years and has presented on a variety of subjects to SMPTE audiences at many section, regional, and national conferences. So tonight's topic, tonight, the presentation will give an overview of the main types of satellites in orbit today. I'm focusing on LEO, of course, low Earth orbit, and a few key use cases that are relevant to the media industry. So with that, I'm going to give control over to you.
Thank you very much. Appreciate that. I assume everyone can see my screen okay. What we're going to talk to tonight is basically, I want to give you an overview and a background of what's happening with LEO. And LEO is an acronym for Low Earth Orbit Satellites, and we'll discuss all of them if we can. And we're going to move pretty quick, so if you have questions, certainly entertain them at the end. Just as a form of background, Canada was 3rd in the world to enter into the space environment with satellites, and we launched some LEO satellites back in 1962, so a long time ago. And the government of Canada formed Telesat Canada Corp, a Crown Corp at the time, and they launched more and more satellites and became a world leader in the satellite industry. And I'll not mention much about Telesat. I'll let our colleagues from Telesat share their own story. In satellite world for the last 40, 50 years, there's been a lot of satellites, but they've all been in what we call geostationary or geosynchronous orbits. And what that means is there's been very expensive, very difficult satellites to get into orbit, and when they go wrong, it's a $500 million failure. So it's quite a big undertaking. There are about 6,000 active satellites in orbit now, but only about 40% of that are between, say, 2,400 and 3,000 are actually fully operational, and the rest are in some form of inclined orbit or semi-operational or dormant state. I wanted to start off, I know this is an eye chart and it's probably impossible to see, but I didn't want you to read it because what I want you to do is just get some scale from this thing. If you have the Earth on the left and the first little blue bar, every pixel on the screen is 10 kilometers. So all the LEO satellites are in that blue area close to the Earth, and there's quite a few, and that includes all the LEO satellites. And then the green is the medium Earth orbit zone, but most of those satellites are about 20,000 kilometers, where the LEOs are all in around 500, 300,000 kilometers, in around that range. But the medium Earth orbits are all around 20,000 kilometers, and the geostationaries, the GEOs, are up at around 36,000 kilometers. So you can see and scale the difference here as to where they are, but what that has a lot of ramifications in latency and a whole bunch of performance factors. So let's just start off with GEOs. we call them geosynchronous because they take 24 hours to do a complete period, a 24-hour period to do a complete orbit. And they appear to be geostationary to us on the Earth, and but they're effectively about 36,000 kilometers up in the air, and but they're going a lot faster. The Earth rotates at about I think 1,400 kilometers an hour, and so we are moving pretty fast right now. But the satellites out in the Clark Belt, as it's called, named after Arthur C. Clarke, the writer, those birds are up and around 11,200 kilometers an hour. So they're really flying very fast, but technically they appear to be geostationary because they're always in the same position. I always joke about the Telesat satellites that if you go to Regina and then go due south to the equator and go straight up to the 35,000 kilometers, you'll bump your head on Anik. It's likewise, if you go to Calgary, go down the equator and go straight up, you'll bump on another Anik. So and they have many other positions. I'm sure they'll talk about that. But effectively, our main orbital slots are out there, 107 and 111 degrees. I've been using VSAT on my motorhome for about 12 years now. And this is a receive transmit system. And I'm not selling anything, so I just put some pricing in so you can see what it costs. That antenna system cost me about $5,000, but I only get 1.5 megabits down and about 256 kilobits up, and it's about $90 Canadian a month, just to give you an idea. And that's a 1.2 meter antenna, and it's a truncated antenna. I have a second antenna on the roof. In my motorhome, I actually carry 4 satellite antennas, 2 on the ground for replacing the rooftop ones if trees block my signals. So I run my own little uplink facility there. If we look at medium Earth orbits, what's there? They're at 20,000. They take around 12 hours to do a 12-hour period to do a full orbit, but they can range from 2 hours to 24 hours, depending on their altitude. And what we've got there is the GPS system. You all have GPS probably in your smartphones, in your cars, and it's talking to satellites that are about 20,000 kilometers away. The GLONASS system and also Galileo in Europe are other examples of the MEO satellites. Now, the LEO satellites, the ones we're going to talk about today, are the low Earth satellites, and they're typically much smaller, very different. When we look at some of the satellites that Telesat has in the geospace, they could be, I don't know, 12,000 pounds maybe. I'm sure they'll have numbers for that. But these LEOs are all around 300 to 800 pounds. I'll use pounds because of US covers most of the satellite construction. So we'll use the American terms, but I'll jump back and forth with metric too. So they're about 500 kilometers in altitude, and they can have an inclined orbit, a polar orbit, or an equatorial orbit, depending on the design. And these LEOs, what they do is they have a small little set-top box like you'd get for your cable or satellite service from Bell or from Rogers. And then they'll have a small antenna about 18 inches, which is a new type of technology called a phased array. It's been around for a while, but it hasn't really been deployed economically. And you can put the antenna, you have to get the antenna to have a clear line of sight to horizon to horizon. So trees are the enemy of this thing, building structures. You just can't put it anywhere. It has to be maybe on the peak of the roof of your house or somewhere dangerous to install. You know, and let's talk about who are the players now. Everybody probably has heard of Elon Musk, and they know SpaceX, and they're in the news almost every week with their launches of their various satellites. And they've been building Starlink, and Starlink is approved right now worldwide for 12,000 satellites. So they did their initial approvals through the FCC in the United States, and then the FCC went to Geneva to the ITU-R and the International Telecommunication Union and got approval globally for 12,000. Now they're asking for 30,000 more for a total of 42,000. And they operate in what we call orbital planes or shells. They're going to use orbital planes are we'll say the path the satellite uses on a north-south basis. And then it could also be polar or across the belly of the Earth at the equator. But they also operate at different altitudes, which we call shells. So there's, you can see the numbers there, 340 kilometers, 550 and 1100. And they've recently requested to get out of the 1100 down to 550. So they launch about 60 satellites at a time on the Falcon 9. They just launched some last week. I think it was Wednesday or Thursday. And they are trying to build this Starship down in Brownsville, Texas area, and it keeps blowing up. If you've seen those pretty spectacular explosions, the next Starship probably will go up Thursday or Friday, so maybe we'll see another great failure or a success. We'll have to wait and see. Pretty fun to watch, but they can launch 60 on the Falcon 9 or 400 satellites on the Starship when they get that working. Early tests have been 100 megabits down with a 20 millisecond latency, but we're already at this point hitting close to 250 to 300 megabits. They're overperforming, but right now they're at a 50 to 150 megabits down. They're an asymmetrical service, and what that means is that they have a different data rate going up versus down. So, but it's unlimited, and they're legal in Canada. The government has been allowing for licensing. They're encrypted, so they have VPN tunnels, and they're running for about $99 US a month, 130 Canadian, and $500 for the equipment, about 650 Canadian. Beyond that, the next player will be Project Kuiper, and it's named after Gerald Kuiper, the professor from University of Chicago, and that's backed by Jeff Bezos from Amazon, and they're getting ready to launch 3,200 satellites on 98 planes and 3 shells, and they're going to have a smaller antenna, 12-inch antenna, and they're going to be at different frequencies, but right now we're understanding that they're going to be at about 400 megabits per second. It's still pretty unclear what the business case is, but what's interesting, Amazon owns Blue Origin, the rocket launching service, but they're going to launch on anybody. They've booked spots with all the Russians and French and their own rockets, so we'll see how they get up there pretty quick. Another player that has satellites in orbit is called OneWeb, and OneWeb's had an interesting life so far. Went bankrupt in March 2019 and was out of bankruptcy in November 2020. They got about $1 billion to restart the company, and more recently Hughes and SoftBank from Japan have put in another 400 million for a piece of the action, but they still need $1 billion to complete their constellation. And they're looking to do about 648 satellites in one shell, 18 planes. So it'd be interesting to see how they go. And they have 146 satellites up already. So they're already in action. Another Canadian player that most people wouldn't know about is Kepler Communications. I kind of like this company. It's doing some interesting things. They have 12 satellites in orbit. They're saying that they're Canada's biggest satellite company because they have 12 satellites. They're all little CubeSats, little tiny satellites. So I don't know, it's a bold claim, but they're working in the KU band, and they grew out of University of Toronto. Very interesting. I shouldn't say they grew out of that. A lot of their people are from that engineering program, and they're building it all here in Toronto, which is very interesting. And you can see their data rates there, about 38 megs down, 120 up. And they can use off-the-shelf equipment. There's nothing custom really, because it's all stuff we have around today. And they're in a polar orbit, meaning they go over the North Pole, over the South Pole, about every 90 minutes each satellite passes. An interesting development is China announced StarNet, and but it only happened after Elon Musk went to China and gave a speech, and he was boasting that they're bigger than NASA, that SpaceX is bigger than NASA, and they're now the world's largest operator of satellites. China got their nose out of joint and immediately announced and approved in 2021 that they're going to build their own system over 5 years and by starting in 2025. And so, but there's a lot of pushback in China. They don't think they need it. A lot of the cellular companies don't understand why, because they have very comprehensive terrestrial networks. So it's being resisted, and it's an interesting thing. It's totally politically motivated. We know Telesat, and we'll let Telesat tell their own story, but they've been approved. They've announced 300 plus satellites, and they've applied for more, and they have their big satellite fleet as well. Another interesting player is Samsung, and they're kind of a dark horse right now. They're proposed 4,600 satellites, and but they haven't confirmed anything. And most people think it's tied to 6G cellular, which is targeting 2030 for launch. We barely got 5G in here. I'm telling you about 6G, and that they see it as a hybrid infrastructure. Most people actually don't know what it's going to do. Is it a commercial offering, consumer offering? What is this? And so we'll have to stand by and see what happens there. I'll just tell you, on March 30th, a couple days ago, we had a very interesting situation where the OneWeb satellites launched 36 birds out of Russia on the Proton rocket. And as the birds were climbing up over the Atlantic, they have to cross through the shell where SpaceX is. And they had all sorts of alarms coming from the United States Space Force, a funny name it is, but the Space Force alerted them, and the satellite came within 190 feet. And this is probably the scariest attribute of this whole thing, is if these satellites collide, the debris will hit other satellites. We'll have a cascading effect. And we almost had it. 190 feet's not very far. So now, Elon Musk, it's interesting, but what you don't know, we all know how rich he is and everything, but do you know he has a Canadian mother, and do you know he has a Canadian passport? He went to Queen's University for 2 years. I'll say 2 of his wives, he's had 4 or 5, and the current one isn't technically a wife, but they have a child together. But the 2 of them are Canadian women that he eats with, so he's got a lot of connections to Canada. And very interesting character to watch. He left Canada, his South African passport, Canadian passport, and a US passport. So he's a child of the world, as I guess they say. And these photos here are from Eastlink Cable in St. John's, Newfoundland. And it's the only Starlink teleport in Canada at the moment. There will be more coming, but it's in a test mode, and they applied for 3 frequencies, but the government only allowed them 1 at the moment, and they're doing testing on the over the Atlantic, and I'll show you that in a second. One thing I wanted to tell you, that these LEO satellites are operated in a constellation, and just like a constellation of stars, there's a whole bunch of them. It's a mass of them, hundreds or even thousands. And the way I like to think of it, the antenna at your home or business would need to be like Tarzan, the way Tarzan swings through the jungle. He swings from tree to tree, and he grabs one vine after the next. I know it's Hollywood and it doesn't really happen, but that's the way these satellites sort of work with your antenna. The antenna grabs 1, 2, 3 satellites, and the most I've seen is 9, but it'll be a lot more later. I saw one person had 36 when the constellation was going by, and I'll show you that here. This is, you'll see it moving. These are the satellites operating. You can see in St. John's, Newfoundland, the teleport there, and there are many teleports planned or built already in the United States for uplinking, regionalization of the content and connection to the internet. And the satellites are all moving, and you can see their angles. Some are climbing up, some are climbing down on a north-south basis. And you can see what we call a train. It was a recent launch and you can see that it was over the Atlantic, heading over the Nordic countries there. Here's from my house, and you can see the antenna is catching 3 satellites at a time, and each satellite, you can see they're 540.4 kilometers or 552, and as they move, you can see the azimuth and elevation to the satellite, and you can see the satellite name, like 7W or 12AK. And then we'll lose the one on the top right in a second. There it goes. And we'll pick up one on the left if we stayed on, kept watching this. But I think you get the idea. It's like Tarzan swinging through the trees. So just grab one, grab the next, and the next incoming will be captured. And right now, in the mode that they're in, we're getting about 3 average. Sometimes we get 0, just so you know, so total outage. But it's still in the early days of build. There we've just picked up the 3rd one. And generally I'm detecting they need to be over 20 degrees elevation for us to catch them. And you'll notice that we're all pointing north. All the antennas look to the satellites to the north of them, which is good for Canada because you know, these satellites will have low traffic due to Canada. One thing, the antenna itself is a flat-faced antenna. So Elon Musk, who's weird about names, he calls it Dishy McFlatface, and it's a phased array antenna, and it actually has some heat on it from the sensor, so it melts a little snow and ice, not a lot, but enough to keep you operational in bad weather that might take out a normal KU or DBS type satellite. So there's a lot of rumors that he's geofencing these antennas, so you can't take the antenna and move it, like we couldn't move it from Toronto to Ottawa because it wouldn't work. The truth is he's not geofencing, but they're creating a cellular model, and your antenna gets registered within a cell, so you only have a 20 to 30 kilometer radius around, and once you exceed the cell, it knows you're out of the cell and it doesn't work. But you can reach into them and get them to activate you at a different address, but it takes about 3 days, so it's a bit of a pain. Every time he launches 60 satellites like he did last week, it's another terabit of bandwidth, and it's about 40,000 users of high definition content. So there's a few things that we've been playing with, is that could I combine satellites? Could I do channel bonding? Can I get more data rate? And Musk is talking about data rates up to 10 gigabits per second. But I think the only way we can do that is through thousands of satellites being up there, and also bringing the multiple antennas and bonding them together in an electronic form after the antenna, like we're showing here. So it's very interesting what kind of data rates. But in rural and remote parts of Canada, you heard Tony mention that in the cities, we are blessed with fiber optics and high-speed internet. So a lot of city dwellers don't really need a Starlink, but in rural and remote areas or industrial applications out in the country where terrestrial internet is not readily available, it would be very interesting. I've also I work with another company I'm on the board of directors with that's doing 5G, and we could see using this satellite as a rifle shot into a rural community and then light up the community with 5G. We don't need fiber to light up 5G. You could put one of these satellites at every base station. So it's kind of interesting. From a media point of view, what could we do? Well, obviously, news reporting, double-enders, stand-ups are pretty easy to do. Double-enders talking from the studio to the reporter. We do that today, but you always see the lag between the Q&A part of it, the interactivity. That could effectively go away with the latency of these LEO systems. We could do communications, comms, audio, radio, all sorts of stuff, sports reporting, weather, beauty shots from remote locations, and other things like interactive media and gaming. Broadcasting is no longer just television, so what else can we do? Elections and now as we get virtual reality, augmented reality, and data visualization come up, we can add in these elements from remote locations. So I see it as a multimedia type solution. In this drawing on the bottom right, you see the phased array antenna on a vehicle that will do beam forming and point the beams at the different satellites, so to shape the beam, unlike a traditional antenna. And we're also talking about linking satellites in space with lasers. So we could do LEO to LEO, of course, they're already getting ready to do that. But what if we did LEO to GEO? And then that would be very interesting from a broadcast point of view and allow us to hit more, more capacity, more locations that we couldn't normally get to without multiple hops. From a device point of view, my keen interest is in mobility, but right now you can't get mobility, but it's proposed. There's Starlink's going to have something they're effectively calling it Starlink Mini that will go on trucks, boats, and airplanes. And Musk is saying he's not putting it on the Tesla cars, but I think the Mini could go on the car when he brings it out, which is a lower data rate service that you see. But we could use it with laptops, tablets, smartphones, digital signage, all kinds of different things, blended technologies, remoteness. It basically unifies Canada. We have a lot of geography in this country, and if we can hook it up, that would be great. And they're already using it in fire. First responders are using test systems to bring emergency vehicles out to an event and then get internet connectivity there. So there's some tests on that regard in Washington State, sorry. And now, what else can we do with all this? And I'll just say Starlink. Edge computing is an obvious answer, where we put intelligence or a computer at the downlink site, such as a 5G site. Artificial intelligence would be another one. And could Starlink be a neural network? And I'll explain that a bit more. Nomadic meaning mobile. And nomadic, we use that term where it's not actually mobile, but we move and stop and then connect. Augmented reality, virtual reality, mobility, big data I mentioned, and then internet from space. If I wanted to connect pipelines or industrial applications, could I do it with this technology or the Starlink Mini that's reported? I'm fascinated by the architecture of the constellation because to me, it just begs to be a neural network. So what I mean by that is that everybody assumes that all 42,000 satellites that Musk is putting up will be used for communication. And I would argue that some could be communication, some could just be big CPUs, crunching vector-based numbers. Others could be used for temporary storage. And we could then tie them into cloud systems on the ground. We create this neural network in space. So we have deep learning on the ground in a cloud. We have deep learning up in space. And then at the edge, we could put machine learning and link it all together. It gets a little scary when you think about this stuff, what can be done. And the parameters, just so you know, with Musk anyways, I have a problem that it's asymmetrical, meaning different upload, download speeds, but you should expect, they're gonna market 1 gig, but you should expect only get about 300 to 400 megabits typical in a downlink, and probably the uplink will be 100 to 200 megabits realistically for your money. Latency 10 to 40 milliseconds, more for round trips like a double ender if we're doing a news show. And everything will be secured. Everything is encrypted today, but then it sort of begs the question, what other encryptions or security measures do I need to take to protect my information if it's confidential, like an election, for instance? It's a pretty affordable solution, although Musk is in negative cash flow big time right now. Each one of his terminals costs him $1,500 US, and he's selling them for $500, and he's hoping to get the cost down over time. Mobility, we don't have it yet, but it's promised to be coming soon. Is it stable? Right now, it's not that stable, but it's getting better and better all the time. And you know, in conclusion, I think that connectivity is the first step, and the connectivity must be transparent for the users. It must be as good as fiber. If we can replicate the power of fiber, then that's really a wonderful thing. It has to be affordable, and it certainly is in that range. And it has to have the data rate and the latency. Add-on features that we bolt onto this thing would be really powerful, and the imagination goes wild here. But content is king still in the media world, and it all depends on what we want to do with it, how we want to use it, but it's all about the content. The satellite system, whether it's Starlink or Telesat or Kuiper, it has to be transparent. It has to be invisible, because what we want to buy really is the content, not the connectivity. The connectivity is fun for the nerds, but it's not what the average Joe wants. They want the content. So, and bridging multiple technologies together, I see that as the future. That's where this thing's all going, is the integration of different technologies like 5G, satellite, AI, artificial intelligence, edge computing, all of this together into one unified story. It brings a lot of value to the world. So that's basically it. I grew up in the large satellite world. This is a facility that I built back many years ago, with big amplifiers and encoders and big antennas. I love big antennas, but now we're going to little antennas, and that's the way of the world. So it's all fun stuff, but I hope that helps. And if at the end of the session, we'll take any Q&A that you may have, and I'll hand it back to you now.
That was great. That was really interesting and informative. So now we're going to get into the next presentation. Okay. So, oh, that didn't, sorry. There we go. There's the slide advanced. Okay, so we have a couple of speakers tonight. So we have Thomas Portois, who's a senior technical product manager at Telesat for the Lightspeed program, responsible for the technical product strategy, offered service definitions and cycles, the priorities and roadmaps. Thomas is an experienced product manager and business development professional in the domain of information communication technologies, with prior positions held at Nokia, Alcatel-Lucent, and Nortel in software and system design, product management, solution management, business development, and pre-sales. So welcome, Thomas. We also have Ted Baker, who's the manager of enterprise and product sale and broadcast sales, responsible for the sales and customer management of Telesat's enterprise and broadcast customers in Canada. Ted is based out of Telesat's Toronto sales office, has been with Telesat since 2006. Prior to Telesat, Ted held various positions at Shaw, Dome Productions, and CTV. And it's good to see you, Ted. And I don't know if Thomas is joining us quite yet. So if he does, Thomas is a product analyst at Telesat for the Lightspeed program, responsible for product development and definition, business requirements gathering, and competitive intelligence and analytics. Thomas is based out of Ottawa and has been with Telesat since January 2020. Prior to Telesat, Thomas attended the University of Ottawa studying commerce with a specialization in information systems and analytics. So I'm really looking forward to the second presentation as well. So with that, I'm going to turn it over to you.
Okay, perfect. All right, so first I'll just give some quick updates on Telesat Lightspeed. So most recently, you know, our investment from the government of Quebec, so a $400 million investment to help bring some business into the Quebec side on the aerospace sector. We also recently announced our partnership with Thales Alenia Space to, they were selected as our manufacturer of our LEO satellites. We also announced recently that we'll be becoming a public company in the coming months there through merging with Loral Space and our PSP investments. So a lot of interesting news there coming as well. And then a little further back was our partnership with the Government of Canada. So that was a $600 commitment from them to help close the digital divide using Telesat Lightspeed. So now I can just jump into a little bit more on the network itself. So Telesat Lightspeed is a low Earth orbit satellite-based, satellite constellation-based global network. So it's an IP mesh network with optical intersatellite links on each of the satellites. Telesat Lightspeed offers global coverage from pole to pole. The constellation is actually made up of 298 satellites in 2 orbits. The first orbit being in blue here is the polar orbit, and then the second inclined orbit in brown as well. And that's again between the 1,000 and 1,300 kilometers altitude. Each of our satellites are equipped with up to 10 gigabits per second of optical intersatellite links. And we have a total of about 750 gigabits per second over Canada. All right, so then on this slide, you can see a simulation of how our network will function, specifically over Ontario here. So you can see the blue and the red satellites, or the blue satellites being the polar and the red are the inclined satellites. And those are connecting with our remote sites, the green lines there, all the way back to our landing station. So it gives you a good idea of what our constellation, or how a constellation will function.
Hi, Tom. I'm back if you can hear me.
So again, Telesat Lightspeed offers a new tool. Oh. Yeah, perfect.
Sorry everyone for that. I lost my connection just as I joined on here. So as soon as I went to video, so I apologize. Tom, do you want me to take over from here?
Sure, that'd be great.
Or not.
Oh. All right, I think he's having some technical difficulties. Sorry, everyone.
Yeah, no, continue on then, Tom. I'm breaking up here, so continue on.
Sure, sounds good. Yeah, so you can see some of our main value proposition for Telesat Lightspeed. So we offer the very high speed links with up to gigabits per second on an individual link. And all of those links come with the low latency as well, targeting the sub 50 millisecond latency, high capacity service. So we're able to put tens of gigabits to demand hotspots, so like an airport or a busy port. As I said earlier, our coverage is global, so you can get coverage, complete coverage from pole to pole, anywhere, anytime. And it's a highly reliable network, so we have unmatched resilience. We allow for very easy of use with quick service deployments, and Telesat Lightspeed is very cost effective, offering transformational economics, especially in the rural and remote areas. As I said, going a little bit more into the resiliency of the network, we do have multiple LEO satellites for higher space resiliency. So not only do the satellites have the inter-satellite links, but we do have in-orbit spares as well too. So as satellites go down, more can be put into orbit to take the coverage. So there'd be no coverage gaps. We have dynamic user links to adapt to the local environment. We offer very high ground resiliency. So not only do we have multiple landing stations for each of our points of presence, but they're connected with the redundant terrestrial links as well too. And we do offer the 24/7 monitoring and support. We are an existing satellite operator with over 50 years of experience. So we know how to keep customers connected through various weather conditions and situations. And a little bit more specifically over Canada, we have about 750 gigabits available with our 298 satellite constellation. And at any point in time, you're visible of up to any 5 satellites. So you're able to easily aggregate capacity from multiple satellites or avoid a certain satellite if there's any blockage in the way. And you can also see an example of our heat map on the right side. So this gives you an idea of the throughput capabilities throughout Canada here with a 1 meter terminal at 99.5% service availability. And then on our launch timeline here, there's 3 key dates for our service launch. So all the way up to Q4 of 2023, we'll be performing customer trials, and we'll go over some of our previously completed customer trials later in the deck. But the next key date is Q1 2024, which is our high latitude service start. So this is when high latitude service is available anywhere above 55 degrees north or below 55 degrees south. And then finally, Q4 of 2024 is when our global service will start. So that's full 24/7 service anywhere around the globe. Then we can move in a bit onto the use cases. Ted, I'm not sure if you want to take over for this part here.
Sure, and I apologize everybody, I lost connectivity just as we were kicking off there, but hopefully everybody can hear me now. And thanks Tom for running with it off the start. So yeah, so we're a little different than the Starlink play, with Starlink acting as an ISP and going to the end consumer. What we're doing at Telesat is filling the need to bring the necessary connectivity to meet the broadband needs of today and tomorrow, not only in Canada but throughout the globe. So we're basically offering a virtual fiber, and as Tom showed you the satellite constellation earlier, a lot of what we're doing behind the scenes is going to be in the cloud, the Telesat Lightspeed network cloud you see there. And again, between the 2 points is going to be the Ethernet layer 2 service, and again, it's called virtual fiber. And again, like Michael was saying earlier, it's nice for the nerds and the geeks to look at and want to know all the little bits and pieces, but really what we're trying to do here at Telesat is offer a service to customers that's very similar to their experience on fiber and with the other customers, the telcos. So basically, if you look at this, we're going to have sort of 4 areas where we focus. Obviously, terrestrial will be a major focus for Canada. Aviation throughout the globe, and again, that's where we go back to our constellation that has complete global coverage. Will fit the over the poles, will fit the aviation world as well. Maritime, obviously, both on the commercial side as well as the recreational side of things, and also government. So basically, if you look at this first service offering, again, Telesat is where the service provider will connect to the network. It'll go over our Telesat constellation and then into these 4 marketplaces. Next slide. So again, it addresses commercial connectivity applications, terrestrial, aviation, maritime, and government as stated. For the terrestrial markets, mobile backhaul, remote enterprise, fixed wireless, health and education, land mobility, and backup and disaster recovery. For aviation, again, commercial aircrafts as well as business jets, maritime, again, cruise, merchant shipping, yachts, oil and gas on their rigs, and then government doing both the terrestrial, aero, and the marine. And then we're also going to be doing some space relay services where we'll be making use of our optical ISL links to provide those services as well as sort of RFK relays. So again, something we should stress here as we go through this is these are all markets we're supplying services to today, and the LEO constellation only improves what we can do by removing the challenge of latency, giving us the throughput we need to deliver gigabits of capacity, and also getting the price point down. So again, we're in the aero market today, we're in the maritime market today, government and terrestrial. So again, lots of experience there. So again, next, as Tom's put forward the next slide, affordable backhaul and enterprise connectivity for rural areas. Again, same look, virtual fiber, Ethernet layer 2 service. Again, service provider connects at a core point of presence, and we'll get into that a little later. But for Canada, to let you know, right now we're looking at 1 in the east and 1 in the west, with the one POP being Tor 1 in Toronto, and then another one projected to be in Edmonton. Each we can feed into and deliver to an enterprise connectivity, a community backhaul, or a mobile backhaul. Again, each one of those would have a user terminal, which we're going to talk about a little later on. And then again, it's Ethernet out into the service offering. So the backhaul usage case, again, just breaking down the picture a little bit more. Again, you have the Lightspeed network with the satellite constellations. Our landing stations, we'll have 2 again in Canada, and then we'll have multiple POPs as well. Each landing station will have somewhere between 8 or 10 satellite receives and transmits that can see multiple satellites at each time. Again, although we've broken out the cloud here with the satellites, all the between the dotted lines is part of the Telesat cloud and part of something we'll be managing on behalf of the customer. Again, customer will connect at a POP with the various cloud internet peering, packet core mobile gateways, MNOs. And then at the end user site, again, they'll have a terminal, user terminal, again, which will go into description of what they're going to look like. And then it's a wireless and fixed wireless play within the community to deliver to the communities at large in the remote community. Enterprise use case, this is more going just to an enterprise, a remote branch in a specific community. We'll obviously use less capacity. Again, our major play here is to do the full community, being able to drop gigabits of capacity into the region. But again, very similar looking diagram and solution. But again, this is just where we can deliver an enterprise solution to a remote branch or a mine or some remote camp if we need to. And then wireless private networks in remote areas. Again, same slide. Again, with the backhaul, Telesat Lightspeed into a remote terminal and into the customer's compact core, compact radios, or a private LTE 5G network. So again, very similar in each case. The goal here is to deliver large amounts of capacity into each region and remote community, removing the challenge of latency, removing the challenge of price point, and removing the challenge of limited throughput. And this is one, we've been speaking to a lot about broadband delivery into the community to meet the consumer or household 50 by 10 and improve connectivity into remote rural areas within Canada and the globe. But this is one which may fit with some of the broadcast community out there, where you have your primary fiber link that breaks or is interrupted, and you have a Telesat Lightspeed solution where, again, you're going over a constellation of satellites, having a user terminal installed in a location, and then making use of the Lightspeed solution as the primary link is restored. Again, this is something we are thinking of for the broadcast community, whether it's at venues, sporting venues, or any type of offering where you need those second critical links.
Okay, perfect. Thanks, Ed. So now I can talk a little bit more about our product offering for Telesat Lightspeed. So the main focus for Telesat Lightspeed is to serve the enterprise market versus the consumer market. So we really want to focus on serving our mobile and enterprise network operators and service providers. So these could be in any of the 4 verticals like Ted was mentioning earlier. Our terrestrial vertical, so mobile and enterprise network operators, aviation network operators, maritime, and government as well. So really want to focus on selling the layer 2 capacity to these network operators, who then add on layer 3 and any other services they might have and repackage to the end consumer. So just again, the focus is to sell to service providers and potentially very sophisticated service users who are able to operate and manage their own networks. But more specifically, our VNO product, or the pool product we're going to be selling, is a smart VNO pool. So this is a dedicated VNO pool you can share across multiple sites. So you buy essentially a pool of capacity, and then you can divide it up and slice it however you need, so as per your service provider's requirements. And we do offer convenient meet-me points for both, either be it through our baseline Lightspeed POPs or our PAS, private access stations, so to allow customers to easily interconnect with the service provider's network. We can go over these in a little bit more detail later. We also offer a toolkit for service providers to dynamically manage and allocate their capacity across their fleet of user terminals as they need. So we'll allow you the tools to go in and set up your services, adjust them as needed, add new terminals, etc. So a lot of things like that. But now that you actually know what the product is, there's 4 sort of key steps to set up your virtual network. So the first is to identify your service regions. So essentially defining where on the globe I want my service to be. So you'll pick from some of our service regions, which I'll show you on the next slide here. And that'll tell us where you want your capacity to be. The next step is to configure your capacity to all the service regions that you selected and your points of interconnect. So within each of your selected service regions, you'll need to define your layer 2 capacity pool at a point of interconnect in both forward and return directions. And so once you set this up, we can configure your interfaces. So be it if you want to use the Telesat customer portal, or additionally, we do plan on having APIs available. You can interconnect with your own systems. So the next step is to set that up. And then once you are on the interfaces, you're able to set up the service to your actual user terminals. So you'll need to configure both your CIR, which is the committed information rate, and EIR, the excess information rate, in both forward and return directions. So the CIR is basically that guaranteed minimum bit rate you'll get at all times, and then EIR is the excess information rate. So it's basically performed on a best effort basis on top of what you're committed to get. And you're also able to adjust the classes of service for each service if you need, with all the traffic being handed off at your configured point of interconnect. And so this slide here just gives you an idea of our service regions right now and the point of presence that are planned for each service region. So a lot in North America here, and you can see as well for some of the other regions too. And then more specifically in Canada, as Ted was mentioning, we plan to have 2 points of presences available, one in the west, planned in Edmonton right now, and then one in the east, planned for Toronto. Both of these will be connected to 2 landing stations, with each of the landing stations being connected by the redundant terrestrial links. So we will offer a lot of options for customers to connect with the Telesat Lightspeed network. And so the first option, which we just showed you, is the point of presence, which is the baseline. This is the Telesat managed facility with public locations that offer very high capacity and high resilience. So it allows telcos to not have to manage their own teleport as well too. So we think this will be the main solution and work for a lot of our customers, but as well, we do plan on offering a private access station, which is for very more special networks. So if you need very secure and private networks, or if you're one of the government customers, we offer the ability to deploy a user terminal at a remote site. So instead of connecting at one of the Telesat points of presence, you're able to deploy your own private access station at a site of your choosing. And so once you've identified your points of interconnect, you'll have your portal or your APIs to control the quality of service and the service itself. So the 2 tools, the self-service portal, this is basically a Telesat-owned portal where you can dynamically control the behavior of your services. You can adjust your capacity, allocate it to different areas, add new terminals, do a lot of things like that. But we know a lot of the more sophisticated customers will also want to integrate with some of their own existing systems. So we plan to offer standards-based APIs to interconnect with be it the customer's billing system or CRM software, things like that. Then on our service performance, we do have some performance objectives I'll go over in just a moment. But as I said earlier, each service will have 4 classes of service to allow you to manage your traffic and prioritize it even further. And then on the actual Lightspeed self-service portal itself, there's 2 sort of main functions there, the self-empowered fulfillment and then self-empowered assurance. So you're able to go through and browse your products, see what services you have available, You can add new terminals, configure your products, modify things like that. And then on the assurance side, you're able to monitor your data to make sure you're getting the specified quality of service, see what your latency metrics are like, different parameters, terminal health. So it's a very useful tool we plan to offer to customers to be able to manage their service. And so within each of the services, there's sort of two main throughput components you have to specify. So the CAR, which you're guaranteed at all times, and that guaranteed minimum bit rate, and then your excess information rate, which is performed on a best effort basis. So this is essentially when we have capacity available on the network, you can get this, but it's not guaranteed as with our CIR. And then again, we have the four classes of service. You can set your CIR and optional EIR per class of service, and each will have some associated performance objectives as well too. You can see here we have a lot of different cause mapping options as well too. And our system also differentiates traffic at the admission and through transport to make sure we're meeting all of our performance objectives consistently. And so a little bit more detail on some of our performance objectives so far. So the one on the left here, availability, is based on an individual service, and this is the full system availability within Telesat Lightspeed network demarcation points. And so this is defined as a basis of total loss of service. So you basically have to not be getting any service at all for this metric to kick in. But on each of the individual classes of service, we have three performance objectives we measure. So the first, the frame delay or latency, our interframe delay variation, and then our frame loss ratio. And you can see here our target values for cause one as well. Each of these will be adjusted for each of the classes of service as well. And so on top of some of our standard product, we have a few add-ons and features which we find could be very useful for customers. So the first is to create your custom service use groups. So if you're a service provider or a reseller and you have multiple customers, in this example, an enterprise customer and a backhaul customer, you can purchase one larger pool together and then create your individual user groups to allocate capacity to each of the groups. So you can divide your pool with a certain amount for enterprise and a certain amount for backhaul. And as Ted spoke about a little bit earlier, the backups, it's very useful for backup sites. So say, we'll stick with the same example, but say you have the two enterprise customers and then you also operate a fiber network as well. Normally your pool, you don't need to allocate any capacity to it because you have fiber, but once it goes down, you're able to take extra capacity from your enterprise or backhaul pools and allocate it to these new sites here so that you can always have your critical services are always up no matter what. And then finally, we offer the add-on surges for certain unplanned events or periods when you think you'll have a lot more capacity, so there's not a large bill shock or loss of service. And so again, just to recap, the Smart VNO product maximizes the benefit to telcos. It's a managed service, and if you choose our Telesat POPs, you're able to not use any, you don't have to maintain any of your teleports, resulting in a lower cost overall. The flexible pool allows you to customize the solution and optimize it as you need, so you can flexibly move your capacity anywhere within a region and share your pool across different sites. And we offer the multiple tools or platforms to control your network and quality. So dynamically manage your services and terminals through the portal or APIs. And then you can configure and prioritize your services for a certain quality of experience. And then on this page, we go into a little bit more detail on our partnership with the Government of Canada. So as I mentioned before, it's the partnership with the Government of Canada to provide a $600 million contribution to Telesat Lightspeed. And the goal of this is to connect up to 150,000 Canadians across rural and northern areas of Canada. And Lightspeed was chosen for this as it is very affordable access and allows for cost-effective, ubiquitous coverage, and is much more affordable than fiber and wireless alternatives for a lot of the remote communities. And we can also offer the high speed, so the 50 by 10 service that's needed. And we also support 5G and LTE services as well. So this allows the Government of Canada to help empower communities, expand healthcare resources, and create new opportunities in these rural and remote areas, ultimately helping to eliminate the digital divide. So that's a bit on our product there. Now we can go into more detail on our user terminals. So this is what you would deploy at the end user site and would use to actually connect to the Telesat network or Lightspeed network. So we have a large family of user terminals planned. You can see we have three sort of types of terminals, the electronically steered antennas, our hybrid terminals, and then our mechanically steered dual parabolic terminals. So you can see they range in different sizes here. Some terminals will be more applicable to certain verticals, but we plan to have a lot to meet each of the customer's use cases. And so you can see our smallest terminal is our 45 centimeter dual parabolic, ranging all the way up to 240 centimeters, with the larger terminals being able to support much higher throughput rates, up to multiple gigabits per second to a single site. And then to go into a little bit more of the meat of things, this is what's included, all the components in one of our standard performance terminals. So it's made up of 2 antenna subsystems, 1 buck and 1 LNB per dome, and then 1 IDU modem. And then you can see in the bottom right here our UT architecture. So again, the ODU comprised of the antenna, the RF modules, the ACU, and the power system. And the indoor unit is the modem, control processor, internet functions, interface functions, etc. Sorry. And then out of our planned user terminals, we have 4 that we're planning to offer right at the beginning of service. So you can see they're all dual parabolic terminals. This is just for the terrestrial vertical. But you can see we have the 4 types, 1 65 centimeter option, 2 100 centimeter options, and then a 240 centimeter version. And you can see some of the key size, weight, and power figures for each of the terminal types here. The main difference between the 200 centimeter options being one uses a 3-watt buck where the other uses a 20-watt buck as well. And we also show some of our CIR and downlink CIR and uplink rates. So these are key. We can get hundreds of megabits per second to single terminals here. And this is in CIR as well too. So this is the guaranteed minimum bit rate you'll get. You can obviously get the higher peak and burst rates as the capacity is available. And then you can see we're targeting these terminals to be available by Q2 of 2023 or Q4 for the 65 centimeter version. As I said before, we do have a lot of other terminals being developed too, but this is just what we plan to offer at the beginning of our service. And we do have a lot of add-ons or optional features you can get for customers who don't want to go with just the baseline terminal. One of the main ones is for customers who have higher data rates or need more capacity. We do have the high performance terminals available, so these can get much higher data rates. As you can see, over almost 2 gigabits on the downlink. And we do this by adding in more modems to the terminal. Whereas the other one had 1, the high performance would have 4 or 8 IDU modems. And as well, we do offer a redundant configuration for customers that need high availability. and these are comprised of multiple user terminals, and we have the ability for load sharing as well too, if there's very high availability requirements. This slide here just gives some guides on the operations and installation here. I won't bore everyone with the details, but it's about, you need a minimum of 15-degree elevation and about 360-degree azimuth. When this results in about 67 meters between radomes. But on the reliability and maintenance side, our UTs are designed to be highly reliable enterprise-grade product. We expect the life cycle to be a minimum of 8 years, and our design target is 100,000 hours mean time before failure. And then finally here, we just give you an example of a dual parabolic installation. So on the left is one version that would be more applicable for telcos. So this would be beside a wireless tower here. And you can see we're using 2 pole mounts for each of our parabolic antennas here, and that comprise the LEO terminal. And then as well on the right side, this is one of the versions of our non-penetrating mounts that are deployed on top of shelters or CCANs. It's more applicable for up north, more remote communities. All right, so that's a little bit more on the user terminal. Ted, I'm not sure if you want to take over the competitive comparison here.
Sure, absolutely. Thanks, Tom. So Michael did an excellent job in the first session, sort of summarizing the differences between the various LEO operators and some of the other MEO operators. This is just a quick slide, sort of summarizing Telesat Lightspeed is the only global enterprise grade network with maximum flexibility versus the other planned systems. And again, as things developed, as Michael stated, over the next coming years, some of these check marks and X's will change. But again, I think the key thing to take out of here is, we've tried to hit all the key points here, which is high focus capacity, low latency, low cost, the resiliency, as Tom explained, global coverage, which is essential for our maritime and our aero business. Another important part is the priority of spectrum rights. We have 4 gigahertz of Ka capacity, right? So there will be some coordination required with the other companies, like Starlink, to work with us, and that's currently happening right now. So, but it is a key feature to our offering right now. And an operational experience, I think we let off the top, and I think Michael even referred to it. Telesat's been around since 1969. Operating a geo fleet of satellites since that point in time, and now moving into the LEO world, and we'll just hopefully be best in breed as we go to this next stage. Regarding Starlink, I mean, what they're doing today is excellent. We're happy that they're in the marketplace as well, because they validate the solution of satellite. For the last little while, it's been as broadcast has changed, there's been a move away from satellites, but these companies all actively moving forward, again, really validates the use of satellite to deliver broadband and the necessary connectivity that the globe is going to need, the global market, especially as we're in these pandemic times. So again, and with the Starlink and the Telesat Lightspeed, we are sort of going after 2 different markets. With the Starlink focusing on a commercial play and acting as an ISP, and Telesat, really being a backhaul supplier into communities to make sure that rural communities have the necessary bandwidth they require to meet the digital divide. A slide here on SpaceX, again, designated for the consumer market, potentially not a solution for the commercial market. Michael had some good slides on some of the work that could be done with their terminals and antennas, linking them together to deliver some increased capacity. But we think our solution for the community market is the right one. But yeah, just going through there again, I think Michael summarized this. It's a large constellation, getting bigger by the moment if they do go up to their full amount of satellites. Our satellite constellation, is going to start at around 300 satellites, and we'll move to, a maximum of 1,600 down the road. Relatively short satellite life, 5 years projected. Again, as time goes on, that may improve. Again, there's some reporting of failures, but again, I think they'll work their way through that. So I'm not going to go through each bullet point here. I'll leave it for individuals to read on later. But again, I think Telesat's got a good solution go forward for the community marketplace and the rural communities of Canada and the globe. And I think we can work together and complement each other with the consumer play of SpaceX and our play as well. So, and a lot of analysts feel that way as well, that the two organizations can survive. Quickly here on OneWeb, again, their constellation's a little different than ours. Just a chart, a bit of a diagram here to show you sort of an example of throughput using the fixed uniform distribution of capacity on their OneWeb. Into the region marked in pink there, they can get about 500 megabits, whereas with our ability to focus capacity, use beam hopping, and the system we have deployed and the number of satellites in view, we can get into the same region about 50 gigabits of capacity. Over the last couple of years and continuing, we've been doing multiple successful demos with our LEO Phase 1 satellite. Again, they're listed here, a lot of voice, government work, Global Eagle in the aviation markets have done a lot of work with this as well. So again, a lot of testing going on with the different verticals. It's continuing on now. We're actually looking at some members of the broadcast community in Canada as well to do some testing this summer. Hopefully with COVID hopefully easing a bit, we can get back to that. But yeah, a lot of successful tests over the last 2 years in continuing with the various verticals. And again, one of the big ones was we did the first 5G over satellite backhaul over Telesat LEO with Vodafone. World's first live test of 5G services connected back in April of 2019. Tests included live transmissions of 4K and 8K video via Telesat's LEO 1 satellite, connected to a 5G network along with video calls and web browsing as well. Test results confirmed a network reaction time of about 18 to 40 milliseconds, among the lowest ever for a satellite connection. And again, it just shows the strength of getting away from the geo latency challenge, which is upwards of 600 to 800 milliseconds. So again, getting down to the 18 or 40 will bring us into the realm of where we have to be go forward. And I think with that, I think that's we're about 8:30, but I think that's the end of our deck right now. I apologize for my connectivity issues off the start.
I think it's ironic that you
right, as you said it.
Yeah. So
and I would thank Tom for sort of leading us through the initial dialogue there.
Yeah, so a couple of quick things. First, a big thank you to Thomas there for jumping in. That was not planned, that switch of who's on the deck, etc. So, you were very good and very fast.
It was not.
So huge thumbs up for that. And also a thank you from me for the presentation. I found it really informative. I think I know enough now about satellites that I guess, we're going to talk to David, the owner of Ross Video, primary owner, and we're going to start our own satellite division now because I know so much now what you guys have all told me. Don't worry, we're not going to be a real competitor, I doubt. So with that, I'm going to pass it over to Ethan. I'm just going to change the presenter to me to share my screen. And then what we'll do is we'll open up to questions for everybody.
Perfect. And if we could have Michael, Tom, and Ted join us here on video, if that's possible. Perfect. Thank you, gentlemen.
Yeah, I think
So-
we'd also, if we could have Thomas Portier join as well, that'd be great from the Telesat team.
Yes. Perfect. So we do have a few questions that have come in so far. I've got one myself. I'm going to start off with this one just to touch on something Michael started with. So maybe going back an hour or so. Michael, you mentioned in one of your slides filling the entire lower orbital space, and I think you said Kessler syndrome, so like the cascading collisions. Is that a reality based on where all those competitors in this space are going? Is that something we have to be concerned about?
It's I have a very good friend. I won't name her, but she's a PhD at the University of Toronto program, and she told me that's their single biggest worry is the collisions. You know, if Telesat's up higher and their shell's higher, there'll be a way, but they still got to transit through this web of this fabric, if you will, of star choice. So it's pretty tricky situation, and it's only going to get worse if Elon Musk gets his 42,000 satellites. Now, space is called space because it's big. There's lots of room. So if we can get to a higher orbital shell, you know, for Telesat, they'll be fine. But you know, will the Starlinks bump into each other? You know, and what's going to happen? It was pretty close last week, 190 feet. It's really, really close, and so we'll see what happens. But the worry that I was told is the cascading. You know, all the broken pieces flying around. And Ted made a good point too about the lifespan. The idea is they're going to just burn up on reentry. I'm a little worried about that. We saw the, I don't know if you guys all saw what happened about a week ago. One of the stages of the rocket failed to do a burn, and it broke up on reentry, and everybody in Washington State and BC, Vancouver, got this incredible light show that's on YouTube videos if you haven't seen it. It was remarkable what they saw going by. But pieces did land in Canada. So, you know, a little scary there again, but and the astronomy folks, I do astrophotography, and that community really hates all this as well, because we're, you know, theoretically blocking out the night sky with all these birds. But again, a lot of politics and emotion there, so I won't go into that.
Thank you. Question for Telesat that I see here from Willie Perez. It says, can we connect the sites directly so that they can send ASI signals from point A to point B? And does it support IPv6?
Thomas, could you maybe take that one?
Yeah, can you hear me?
Yep.
Yeah, so the first question is about connecting remote terminal to each other. So that's a setup, connectivity that we support, a service between two endpoints that are made up of two user terminal, the one that you saw from the presentation. Typically, we have application where we could connect to point on the globe. We have long distance connectivity service that could be of interest to enterprises. We have some example of enterprises like doing high speed trading that are always very interested with shaving off as much as possible any latency from a terrestrial connectivity service. So in the case of Telesat, we can simply connect two terminals through the constellation, and then having the connectivity path to use our optical inter-satellite links, which, as you know, with the speed of light being real in space as opposed to be less on through glass. We can achieve actually very fast connectivity service. As an example, between two user terminals. The second question, I think, was what was it again?
IPv6 support.
Yeah, we are completely agnostic to the layer 3 layer, since we provide, in fact, maybe you missed that, we provide a layer 2 Ethernet service, on top of which service providers can transport whether they're IPv4 or IPv6. We find out that Ethernet is probably one of the best and easiest technology to connect networks. And the premise of Lightspeed offered services is to offer that same simplicity to terrestrial service providers that are used to that, and even not think about that it's going through space.
Thank you. Question for Michael, and Telesat's happy to weigh in here if needed, for Martin. The differences and potentially benefit, I guess the benefits of KA versus KU band. Telesat threw up a slide where some of the competitors were using KA, some were using KU. Michael, do you have any thoughts on why one solution over another?
Yeah, on the well, it's all about rain fade and snow fade and affecting the antennas really on the ground. But there are windows. If you ever, I took the slide out. My deck was too long, so I removed it. But I had all the window frequencies in a slide earlier that that would show where the impact of a dry sky versus a wet sky, and what sort of fading we get. It's also one thing that's different about these LEOs compared to GEOs is the angles. You know, when we built ExpressView, I could measure a 40 dB fade because the raindrops would hit the pavement in the parking lot, and if they bounced a foot up off the ground, I knew it was a 40 dB fade, and we were out of service. We had power control on the ground. We had power control on the birds, on the Nimics, and we combined the two of them to give us a tolerance to fade. But that's in a specific angle, a specific azimuth and elevation. With these LEOs, they're looking at many angles. All the satellites are in transit. So as a result, you can move in and out. Like if you live here in Ontario, in Toronto, our rain is very cellular, and at KU bands, it's about a 6 dB fade typically in Toronto. In Winnipeg, it's 1.1 dB, and Regina 0.9, Vancouver 4 dB. Everybody thinks it rains a lot in Vancouver, but they have a lower statistical average fade than we do here in Toronto. But our fades here in Toronto are cellular. So meaning the storms come in, they last for 10, 15 minutes, and they come in like a Mack truck and then they're gone. And so it's a very temporary type of rain fade. On Starlink, by the way, just so you know, is using 3 different bands, not just KU. They're using different frequencies as well in the KA as well. So I assume you were just saying KU because it's what's coming down to the ground. But inter-satellite, they're using frequencies, they're using lasers as well. But it's, I'm quite concerned, even our 5G millimeter wavelength is going into the higher frequencies, 28 gig, 24 gig, 38 gig, 40 gigs. So how's that going to impact on distance, bandwidth, data rate, all these issues? We still have a lot of learning to do, so I won't pretend to say I know all the answers right now, but I'm going to suggest to you that we already know what KU band will do quite well because we've been using it for decades, and I'm quite comfortable with it. It's probably not a big problem, but when we get up into the higher frequencies, it's going to have different impacts. Now, I wrote an article last year that I forecasted that Starlink would have huge problems with snow in these frequencies. And that's turned out not to be true because the antennas use a phased array. They're actually generating heat in the antenna, and the antennas are melting the snow away. So they're able to do that quite effectively, probably for about, I'll guess, 70–80% of the scenarios you might run into. They're actually able to survive and keep running. So they're performing far better than I anticipated they would, which is good news if you live in Canada, right? But you know, I'll throw over to Telesat. What do you guys think about the fade, rain fade, snow fade?
And I'm also curious if you can comment on the higher frequency 5G interference that Michael mentioned. Is that something you have to contemplate or mitigate for in your solution?
Well, I'll start off and then I'll throw it off over to Thomas to comment as well. Yeah, Ka-band obviously is a higher frequency. The rain fade, you know, as you go from C to Ku to Ka-band is more of a challenge. We have been operating, you know, the Ka-band satellites in our geo world for quite a while now with our Telestar 19V. So a lot of lessons learned there for rain fade and how to manage it. And again, I think we're designing our systems and our user terminals and our satellite constellation to mitigate as much as the Ka-band rain fade as we can. So I'll turn it over to Thomas to sort of speak to some of the things we're doing.
Yeah, so I think what is interesting is to understand how maybe a LEO K can be different than the GEO K, and how it would be better to mitigate some of the well-known effect of K that are an issue for any wireless transmission, whether it's 5G or a GEO satellite that is even more difficult because it's so far away. So LEO has additional tools in the toolbox to mitigate really, and one of them is also combined with the Telesat LEO specific that will be onboard processing, equipped with onboard processing, so they will be able to demodulate and remodulate the signal and apply different resource allocation techniques that are kind of new and unique to us, which are the beam hopping. So one of the mitigation technique that we'll be able to add to the toolkit, which you know, will be doing all the good things about doing adaptive power control, changing the code modulation, changing the size of the carriers. But in addition to that, we will be able to play in time into the beam hopping to use additional beam hopping time slot in to give to the terminals that may be affected and would by rain and having a lower channels during this adverse condition. So that's one thing that is going to be unique to Telesat LEO. The other thing is that unlike GOK, when you are affected by a link being affected by weather, things are moving, are changing. And it's not going to last very long for LEO because there is a variation into where the terminal is pointing. And also, we have always multiple choices. As you recall, on average, we'll have between 5 to 7 satellites in the field of view of a terminal to choose from. So we'll be able to make decision and switch satellites. And also, that's number 2. And number 3, we think that we should be able also to, at some point, use weather prediction to understand where are the rain cells approaching from where they are coming from, to also use that for our system resource management to select a satellite that would be allowing to avoid these rain cells that would be coming. So that's kind of a third techniques that kind of really differentiate quite a bit LEO KA versus a GOK, and even a LEO KA versus, let's say, a LEO KU that may not have all this digital processing capability on board and also paired up with what would be on the ground. So there are a lot of cool things that Telesat here will be able to do. And lastly, relation to 5G, in fact, what I want to say that one of the benefit of KA is that we have a lot. Telesat has about 4 gigahertz of spectrum rights, and we'll be able to have also we have dual polarization, cross polarization. So we have in effect 4 gigahertz on each forward and return. So we have a lot to play with, so that we will just comply to the 5G regulation, where in certain countries they will take a bit off from us. We will not be so much impacted to basically have enough to allocate to the terminals and to our landing stations, really. So this is not perceived to be a problem.
Thank you. Next couple of questions I'll throw to Michael. I think we may have covered some of this, but, and I know you mentioned it on one of your previous responses. What's the expected operational lifespan of an average LEO satellite, and what happens when they're spent? I think you said they may burn up on return, but maybe you can elaborate on lifespan as well.
Yeah, I would think we heard 5 years. I think 5-7 years. Now, having said that, there are LEO satellites in orbit today that are far exceeding their lifespan. Mm-hmm. So that's promising. There's some that are dead in arrival, you know. So you know, it's a variable thing. But let's just say average 5 years. But I've seen some that are 7 and longer years. It's Canadian satellites specifically. I'm thinking of some. So that University of Toronto has. So little CubeSats kind of things that are really performing well. But you know, they can burn up. They're designed to burn up. Just so you know, the materials used. And I read a paper. Japan is looking at building CubeSats out of wood, which made me laugh. But hey, why not? If it works, I don't know. It's striking to me because normally we're using very different metals and composite materials and all sorts of stuff. But you know, if you think about it, they get a rocket, they put them in orbit, so they arrive in orbit. They don't have to burn through to get up there. They're protected on the way up. So on the way down, it might be interesting. But there's a lot of CubeSat designs right now. It's very affordable technology, and a lot of companies are doing it. So, but burning up on the re-entry, I think on the GEOs, Telesat, you've turned some towards the sun and hit the last bit of benzene and told the old birds to go fly into the sun. I remember one time that happened, but I don't know if that's normal. But there's different ways to do it, but basically burn up on re-entry.
Perfect. Ted, did you want to elaborate on anything?
No, I think that's a good answer. I mean, it's you know, our satellites are projected a little longer life than that, but again, I think as Michael said, I think time will tell as these things get up there and run their course.
Perfect. Next question from Jeff Moore. Are the Lightspeed satellite to satellite links actually optical light beams?
Thomas,
Yes,
I'll let you.
right. Yeah, they use actually a waveform and a modulation that is similar to what you would have in some optical transmission network on the ground, and it's similar technology, just being run directly between two optical transceivers in space.
Excellent. And there are no further questions. I have one last one to close, and then maybe we can throw back to Tony and Troy for closing arguments. One thing Telesat mentioned, the private access station. I think Tom had mentioned. Is that something that, I think you may have said telcos, but something that broadcasters or telcos or BDUs would use for content acquisition or distribution, or would that be considered overkill? And they primarily go through a third party and then backhaul over fiber?
Yeah, I think it would be overkill. I think that even for broadcasters, our primary offering of to the POP and having a user terminal wherever they are is probably the natural solution for them.
Okay, thank you.
And with that, we have on the broadcast community, we have had again discussions with some of the OCUS group as well within Canada to see if there's a solution for them. And I know, I think it was OneWeb had a session with BBC recently speaking to the use of LEO for the broadcast and specifically OCUS. So lots of work still to be done.
Thank you. Thank you guys all so much for your time this evening.
Thank you.
Thank you.
All right, thanks, guys. Actually, I was just gonna ask a final question. How much does one of these LEOs cost? Like, what's the cost for one of the satellites? Actually, I don't know if it's $1 million, $2 million, $3 million.
Of my pay scale.
Yeah.
Fair enough. All right. Tony, I'd want to know if you wanted to add any closing thoughts of your own as well.
Yeah, I find this very interesting. One of the questions I had, I put in the chat room, but let me just ask it quickly. That's okay. Are these satellites, the receivers at the consumer end transportable? So do I get to play satellite at home, and do I get to take it to the cottage, or do I have to buy it twice? And in Michael's case, he's got an RV. Does he get to take it on the road with him? So, or is this a one only fits one, and you got to buy? In Michael's case, he'd have to buy 3 of them. Just wondering.
Yeah, I think from the Telesat perspective, ours are pretty much locked and loaded at the site they're at. I mean, they can be moved around, but they're not mobile. I think Michael addressed that a little bit earlier with the range that a system can sort of fall within and then moves. But I'll let Michael address that.
Yeah, right now, Tony, assume that they're fixed with Starlink as an example. But Starlink has gone on record at the satellite conference last week, I think, that they are doing a mobile unit for trucks, ships, and motorhomes. Yay for me. And get rid of the big old VSAT and my Hughes network off the roof of that thing. And but that'll be apparently September or so. They're talking about it, so we won't know what it is. They keep their cards very close to their chest. So, but mobility is really vital, and a lot of people speculated that Starlink will go into Tesla vehicles, but Musk is saying no. But I don't believe it. I think that he'll put it in the cars someday, and not too far in the distance. And it may not be Starlink, but a Starlink Mini that is rumored right now. So we'll see what it is. But there's going to be variations. They have also said last week that they're not going to do price tiers. If you only wanted 100 megabits, you pay $50. You want 400 megabits, you pay $75. They've said they're not going to do that. They're just one size fits all. But again, will that last past a year? I bet they'll start to change, and they'll have to respond to competition from all these other players, because if they're, right now there's no competition. They can say and do whatever they want. But very soon, in a year from now, it's going to be a much different market, and then their product offerings will change with it, I think.
Interesting. Okay. Tony, anything else that you wanted to add?
No, I think this is a great meeting. I think this is one of the first ones we've done with co-chairing with another section. I think it was great. It brought everybody together. I think I remember seeing 122 or 124 people at one point were tuned into us. There was a question I saw that, is this being recorded? It is, and it will be available. There will be an email sent out from webinar with those details. But yeah, I think this is great. Troy, I don't know what your thoughts are.
Yeah, no, this was awesome. The subject matter was really interesting. I was really happy to see that. And it was great working with the Toronto chapter this closely. I think this is the first one we've done of this nature, and I think it went brilliantly. It's great. So before we sign off, a reminder on keep an eye out for the the Montreal symposium we mentioned, and obviously please go to the website that Tony was poking you at earlier for the Toronto Technical Conference as well. Cool. All right.
Cool. Thanks very much.
Thank you.
Ted, Michael,
Thank
Thomas,
you.
Domain. Thanks
Good
very
day.
much.